Okay, we're going to move on with 7.8. It's called improper integrals. I put converges and diverges up here. I'll explain what that means in a minute. First of all, what is an improper integral? An improper integral is going to be when one of my limits of integration is infinity or negative infinity or both. Or if one of my limits of integration happens to be a vertical asymptote. The way we're going to do improper integrals is I'm going to change infinity to be a number and I'm going to convert it to a limit. So I'm going to change the integral as a approaches infinity to be the limit as b approaches infinity from 1 as a goes to b. So essentially I'm going to put a b in for my infinity and I'm going to change it to a limit because now we should know how to do limits extremely well. So I'm going to find the limit as b approaches infinity from a to b of this. I'll show you how it works out, but your first step, most of the problems we do and most you'll see are problems like this that go from a number to infinity. So what we're going to do is we're going to put b in place of infinity and we're going to change it to the limit as b approaches infinity. For the cases that go from negative infinity to infinity, what we do is we just pick any c, any arbitrary c. So a lot of times we pick 0 if it's easiest. And then what we'll do is we'll go from negative infinity to 0 and then 0 to infinity. And then we convert it back to a limit process. We don't see those too often, but I'll give you some. We'll kind of go over it. I'll show you how to do it. I'll write out all the answers when we get there. Now, if they're both numbers, then if it's in this section, one of them is going to end up being a vertical asymptote. For example, this. Okay, this is what an improper integral looks like. They're going to say, hey, from 1 to infinity of 1 over x, or from 0 to 1 is the example I just kind of showed you. The idea with this is 0 is a vertical asymptote. So if you graph this, 0 doesn't exist. Okay, so the question is, does this limit exist? Same thing here. I'm going from 1 to infinity. Does this limit exist? Well, when I say that, here's the idea. We know that an integral is the area under the curve. So that's kind of how I taught you the conceptual understanding of what this means. So if I graph 1 to the x, and I want to know, hey, what's the integral from 1 to infinity? I go to 1, and then I want to know the area that is collected between that curve and the x-axis from 1 to infinity. Well, there's two things that's going to happen. Some curves are going to get super close to the axis to where there's really no area there. And if there's no area, then we can actually add these up, and we're going to say that that converges to a particular number. We can find the area under that curve. It's going to be a constant. But if this curve doesn't get as close to the axis as we want, there's always going to be a little bit of area. And in this case, we can't add it up because we just keep going and going on forever and ever. If it doesn't add up to be a constant, we're going to say it diverges. So in doing these problems, when we change them to limits, if we get an infinity, that means that we can't add it up because it's going to be an infinite number of areas, continually going. But if it does turn out to be a number, that means that it's going to get so close to the axis that we can actually say we just don't need to worry about it. So that's the idea, and you're going to have to do each one in its entirety to figure it out. So how do I do improper integrals? Well, the way we do improper integrals is we're going to change them to limits. I'm going to put a b up here, and I'm going to find the limit as b approaches infinity of the integral from 1 to b of 1 over x dx. So that's your first step in finding improper integrals, is I'm going to change it to a limit, just like I showed you. You can refer back to that. So what do I do from here? Well, the next thing I want you to do is actually integrate this. So the idea is I integrate 1 over x. Well, what's the integral of 1 over x? Well, that's just ln of x. And then what do you do when you integrate? Well, the fundamental theory of calculus says when I integrate, I plug b, I plug the top number in, so I want to find the ln of b minus the ln of 1. If this limit turns out to be a number, it's going to converge. If it doesn't, it's going to diverge. Well, the thing is what is ln of infinity? When I go to plug infinity in here, ln of infinity just keeps going and going and going. So this thing is going to end up being infinity, so this diverges. So this improper integral is going to diverge. If this limit turns out to be a number, it converges. If it turns out to be infinity, it diverges. If you have questions on that, make sure you just respond to me and we'll kind of go over all the details on that. So that example diverged. So now what happens is I go to here. Here's another one. Well, why doesn't this work out? Because 0 ends up being a vertical asymptote. If you happen to have a vertical asymptote, we still set it up like a limit. But then we need to, because it's from 0 to 1, I'm on the inside of 0 to 1, so I want to approach 0 from the positive side. So I change this to a limit, and I'm going to integrate from a to 1 of this function. So the first step is to change it to a limit. The next step is actually integrate this. Well, this is really x to the negative 2/3. If I rewrite this, it's x to the negative, actually it's x to the negative 1/3, I'm sorry. It's x to the negative 1/3. Now, if I want to integrate that, remember what you do is you add 1 to this to make it x to the 2/3, and then when you divide it by 2/3, you really multiply by the reciprocal. So I integrate this from a to 1. So what I do is I plug 1 in there. So I get 3 times 1 to the 2/3 power over 2 minus 3 times a to the 2/3 power over 2. And I want to find the limit as a approaches 0 from the positive side. So how do you find the limit? Well, you substitute in. This case, I get 3/2. But when I plug 0 in here, I get 0 over 2, which is 0. So I end up getting a number this time when I find my limit. If you get a number, that means that this improper integral converges, and it converges to 3/2. So the area under this curve is going to end up being 3/2. In doing these limits, just a few things I want you to remember is 1 over infinity will be 0. If you get something that's a fraction, if the bottom's growing bigger faster, it's going to be 0, remember? So in this case, e grows faster than that, so that would end up being 0. And the last thing is sometimes when you integrate, you're going to get arctangent of infinity. And this is the toughest thing for a lot of kids to understand. But the idea with this is, when I say the arctangent, I'm saying what angle, when I take the tangent of it, do I get infinity? Well, if you remember, the tangent graph is this repeated over and over. Well, pi over 2 was the first vertical asymptote, so when arctangent is approaching infinity, that means I'm approaching pi over 2. So if you ever see the arctangent of infinity, you need to replace that by pi over 2. There will be some questions as we go, but I'll just keep in communication with all of you. Okay, thank you.